Okay, so we're going over the inverse of quadratics, right? So they've given us 4 points here, and you're right, we could put up a Cartesian plane here, and 0, 2, 12, 3, 23 have something like this in terms of what it looks like. And then we could draw our dotted line, so let's actually put permanent on here. Well, we're just going to do a rough sketch. So we know we'd have 0 and 0, and then 1 and 3, 2 and 12, and then 3 and 27, something like this. So we have a pretty thin looking parabola. Okay? And then we know that to graph an inverse is technically on a 45-degree angle, right? So then the inverse of this guy would maybe somewhere like this, and go like that, right? And we'd have to try to flip it. But actually the easy way to do this is because they've given us the coordinates. Okay, that was our black one. So in other words, this is our f at x coordinates, the inverse coordinates, should do it in red because the graph's in red. The inverse coordinates are going to be really easy. Okay? That's the same, and I'll explain why after. But this one, tell me if you can figure out what the pattern is. What do we do here?
We switch the x and the y.
We just switch the x and the y. So everything just becomes flipped. So 0 and 0 just stays at 0 and 0. But when you flip 1 and 3, it becomes 3 and 1. 2 and 12 becomes 12 and 2. 3 and 27 becomes 27 and 3. And that's how we would plot out the inverse of the function once we have the points. Okay, so let's say the next question is they ask us to inverse this graph, example 2. So they've given us this parabola. And one thing we know about an inverse is technically, it's the same as flipping it on a 45-degree angle, this graph. So in other words, that's like having a line right to here and folding this graph over. So if we were to fold the graph over like this, okay, then this becomes some kind of shape probably like this. But we need to find the exact points. So one of the easiest ways to do this is to find the coordinates, right? So one of these coordinates is -2 and 3. Another coordinate is -1 and 1, -3 and 1. Then they had -4 and -5, and 0 and -5. So we'll put those points on the side here. -2, 3, -3, 1, -4, 5, along with -1, 1, and 0, -5. Now, if we were to invert all of these, okay, so we switch all of them over, we'll get our new function. So in other words, we do 3, -2. Of course, these are our x and our y values, so we switch the x and y's now. So now the x is 3, the y is -2, 1, -3, 5, -4, 1, -1, and -5, 0. So we're going to plot these. 3, -2 is over here as a vertex. 1 and -3 is here. 5 and -4 is down here. Okay. Yeah, we got that. 1 and -1 is here. One of those points is really up. -5 and 0. -5 and 0. This point here is very off. What did we make a mistake with? Because we can make a sideways looking one with this, but we have an outlier here. So we clearly made some mistake. It probably needs to be roughly here. What did we do wrong here? -2. -4, 5. Okay. So it's actually a good thing we did this. Here's our mistake. The coordinate is -4, -5, but we only wrote -4, +5. So this should be -5, which then makes this -5. So like we said, this coordinate needs to be over here, -5 and -5. 4. That's where the point should be. That's good. We're able to use our logic to figure out what was the problem there. So we plot this. There we go. And we have our new root function. Okay, that's nice. But let's say they wanted us to prove it, that this was the actual function. Well, another way I could do this is I could find the equation of this parabola. Okay? The equation of the parabola in vertex form, because I know the vertex is -2 and +3. Okay, so vertex of the parabola, -2 and +3. I know if I go to vertex form, which is our function is f at x is equal to ax minus h squared plus k. So we can put out our a, h, and k. And our -2 is going to be our h value, and our +3 is going to be our k value. So we can plug those directly in. Still looking for a. Don't know what a is. X subtract -2 squared, and then +3. Now our f at x is technically equal to y, but let's keep going with this. Y is equal to a x plus 2 squared plus 3. Now I don't know what a is. Do you know a way I could find this? I have the other two variables, x and y, and I actually have many of their points. They're all up here. So I'm going to go about just using one that looks simple enough. This is an x and a y value. X is -1, y is 1. So I'm going to come down here and use that. X at 1, y -1. And we're going to use those to plug into the two coordinates. So this will be my x coordinate, and this will be my y coordinate. That way we can now isolate for a. So we get -1 is equal to a 1 plus 2 squared plus 3. Okay. I will simplify what's in those brackets. -1 is equal to 3 squared. Yeah, so we get 9a plus 3. Does that make sense? We move the 3 over, what do we get? Yeah, it becomes 1 subtract 3 is -4 equals 9a. Having a lot of trouble looking at coordinates today. Okay. X was the -1, y was the +1. I knew that didn't make any sense. Which means this is +1, this is -1. So it's going to change a couple things for us. -1 plus 2 is going to be what? 1 squared? 1. So it's just 1a. Now when we move 3 to the other side, what are we going to get?
Oh no.
Yeah, well, it becomes, you're right, -2. So our a value is -2, which makes sense because there's a parabola that faces downwards. So our equation, which is this guy here, is f at x is equal to a is -2, x plus 2 squared plus 3. Okay? So we've gotten the equation of the vertex, and then to find the inverse of this. So if they want the inverse, we switch our y and our x values, right? Here's our x and say here's our y. So now what we'll have is x is equal to -2, y plus 2 squared plus 3. Now let's start moving things over. What do we move first? And what is that going to become? So x minus 3 is equal to -2, y plus 2 squared. Then what? How do I bring that over? Yeah, because it's multiplication, so we're going to divide by -2. So we then get x minus 3 divided by -2 is equal to y plus 2 squared. Then what? How do I get rid of the squared? Yep. Square root both sides. So now we're left with square root of x minus 3 over 2 is equal to, sorry, -2 plus 2. And then finally, I'm going to switch sides, okay? Y will be equal to,
X minus 3.
so I'm going to put plus or minus, because remember we do that because we can technically get two answers. Plus or minus the root of x minus 3 over minus 2. Is it plus 2? When I move that 2 to the other side. So here's our two functions. This would be our inverse. I'll get rid of the y and we'll actually put the inverse in. So we did more than we needed to do, but just to show you how they relate to each other. Okay, so we did a whole lot. The easiest way is obviously if we just invert all of the coordinates. But the other way we could have done it is found the vertex form, which we had trouble with because we had trouble plugging in the coordinates, and then inverting it to our inverse function. So then our inverse function, the yellow one is our original, so we'll highlight all of it. And the green highlighted one is our new inverse function at the bottom. So those are our two functions. So we have our inverse function here. What I'm going to do is I'm just going to factor underneath the root so that you can see. And our inverse function up here when we drew it was in red. Okay, so I'll draw it in red. The inverse of x is equal to plus or minus the root of, and this -2 here, I'm going to factor it out. Okay, and because it's a fraction, well, or it's divided by -2, when it's factored out, it's 1 over -2. That's what it looks like. So 1 over -2, bracket, x minus 3, so they'll stay the exact same, minus 2. And the reason I want to show it to you that way is because if you remember, f at x is equal to function plus. You remember, we have our a, our k, c and d, right? C and D. If we look closely at these, this is our D value, our -2. Our C value here, the 3. Our K value. And our A value is just essentially the number 1, you could say, is being multiplied over here. Okay? It's being multiplied by 1. It's our A value. So, and with that vertex, if you remember the vertex from the original, it was -2 and 3. Well, we could quickly tell that this vertex is going to be 3 and -2, right? We knew to invert them. If we go look at the actual function itself, here's our opposite of 3, right? And -2. So we have -3 in there, but remember it's always the opposite of what we think. They have, whoops, a little too high, 3 and 2 as the inverted vertex. Can be seen in the equation. 3 and -2. Okay, so that can show us exactly where the inverted vertex is. And then this would tell us how much to move our root by. When we normally go to draw a root, we would go up 1 and root it over 1, right? And if we were to go up 2, it's kind of like over 4, the opposite of what we're thinking. Well, because our k value is 1 over -2, technically roots are drawn this way. The negative tells us to flip or invert this. So now it's flipped on the y-axis. It's facing to the left instead of to the right, because normally the roots are drawn to the right. And because it's over 2, it's like multiplying by a k factor, 1 over k, right? It's like multiplying by 2. So we take our coordinates, and we normally go up 1 over 1. Well, we go up 1 over 2 because of our k. We go up 2. And normally we'd go 4, because 4 rooted is 2. Well, we multiply that 2, we go over 8 in this case. So it kind of helps us in terms of graphing this entire inverse. If you see that function, you can find the similarities to it. And that's why we factored the k out, so that we could see exactly what the k is.